Okay, this is a polar problem. Notice that you do get to use your calculator, so we are going to be using our calculator here for some of the pieces. First question says, find the slope of the tangent line when theta equals pi over 2. So remember, anytime they talk about slope of a curve, you should always be thinking dy dx. Now, if you want to do this by hand, this is going to be a little bit tedious. You would have to do dy d theta over dx d theta, but then you have to use these equations, x equals r cosine, y equals r sine, and then do the product rule. But this is a calculator problem. So there is a dy dx feature on your calculator in polar mode. So you're going to type in r equals 2 plus 3 sine theta into your calculator. Make sure your mode is on polar, and you can just type in the r. And if you go to second trace, calculate, your dy dx should be one of the pieces. And at pi halves, you should get 0. Okay. The next one, dr d theta. If you look at your calculator, the same menu, there is a function for this. But dr d theta, we can do by hand pretty easily if you want, because I do have an equation that has r's and theta. So I can just take that derivative. So the derivative of 2 plus 3 sine theta is just 3 cosine. And I want to know what happens at pi thirds, which is cosine of pi thirds is 1/2. So this is 3/2. So this one, doing it by hand is simple. You can still also use your calculator here. Okay, the next one. I'm only looking from 0 to pi half, so quadrant 1. It says there's a point on the polar curve where the x-coordinate is 1. So they're saying that on this graph, your x value is 1. I want to find the value of theta. Okay, you're given x, I want to find theta, so you should be thinking, I need an equation that has x's and thetas in it. That only equation that we know that converts, that we can use, is x equals r cosine theta. This is your x's, this is your cosine. So it's telling me that x is 1, I can plug that in. R is your general r equation, which is 2 plus 3 sine theta. And then the cosine is there. Okay, once you do this, this is just an equation we're solving for one variable. So we can solve any equation on the calculator. So you want to go back to function mode, right? I only have one variable. So put this into y1, put this into y2. Use this as your x windows, so make your x only go from 0 to pi halves. Your y windows, we're trying to hit a y value of 1, so if you go from like 0 to 3, that should be fine as long as you can see it. You're going to find that point of intersection on the calculator, and you should get 1.366 something. So this for sure needs to be written down, and then you just give me your answer, use the calculator to solve. Okay. Last one here says, find the value of theta, and we're only looking at this interval, that corresponds on the curve with the greatest distance from the origin. Okay, so we're looking for, the word greatest is another word for max. So we're talking about max of something. I want the distance from the origin. Okay, think about a polar curve. This is kind of what your polar curves look like. These are your r values on your polar, right? This is r equals 1, this is r equals 2, this would be r equals 3. The origin's right here. So in polar, when they talk about the distance from the origin, it's actually talking about your r variable. So this is really saying find the maximum value of r. Now think back to, how do we find maxes and mins? What's the first step always? We take the derivative of whatever we're trying to find, which is r, and set it equal to 0. So I can do that. And I only care about angles between 0 and pi, so the only place where this is 0 would be pi halves. But I want the maximum, absolute max. So if you remember, besides critical points, which is what we just found, what else do we need to check? We need to check our endpoints, which are 0 and pi. So we need to check 0, pi, and then our critical number. And we need to plug it back into my original equation, whatever we're trying to find the maximum of, which is r. So if I plug in 0 into 2 plus 3 sine of theta, this is going to be 2. If I plug in pi halves, this will give me 5. If I plug in 2, this pi, this will also be 2. Just so this is obviously your biggest greatest distance from the origin. It does say find the value of theta, so my answer that I'm looking for is the pi halves. And this would be your justification.